We're working on a linear programming problem. We have two different types of shirts, t-shirts and sweatshirts. So I'm going to represent X as the number of t-shirts, and I'm going to represent Y as the number of sweatshirts. Okay, now we have lots of things going on here. Okay, so we could make, it takes for the t-shirt 10 minutes to make, and supplies cost $4. For the sweatshirt, it takes 30 minutes to make, and supplies cost $20. So we're working with these constraints on the bullet points. We have at most 20 hours to make shirts, a total of 20 hours for both. Now in our problem we have it in minutes, so we need to change the hours to minutes there. So 20 hours times 60 minutes in an hour, so that gives us a total of 1,200 minutes. At most means less than or equal to 1,200 minutes. So let's write down the actual inequality now. So we could take 10 minutes for the t-shirts plus 30 minutes for the sweatshirts, and we have at most 1,200 minutes. Okay, next one there. You want to spend no more than 600 on supplies, no more than. So that means we want to be less than or equal to $600. Okay, how much does each cost for supplies? We got $4 it costs for the t-shirts, and it costs $20 for the sweatshirts, and we don't want to spend more than 600, so equal to it or less than that. And then the last one says you want to have at least 50 items to sell. So that means I'm going to take however many t-shirts plus how many sweatshirts. It could be greater than or equal to 50 there. Now here in this problem we have a profit objective equation, which is this last sentence here. So the profit on a t-shirt is $6, 6 times X. So I'm going to make that equal to P because that's my profit equation, plus $20 profit for the sweatshirts. So we want to figure out how many t-shirts and sweatshirts should you make to maximize that profit equation, and what is it? Okay, so I'm going to move this up a little bit. I'm going to set up my axes here. Okay, and on the bottom also. Okay, let's take a look at what our intercepts are for all these three lines. All right, so for the first one there, if I cover up the 30y, 1,200 divided by 10 is 120. So that's 120 comma 0. If I cover up the x and divide 1,200 by 30, I get 40. So the biggest one right there is 120. For the next one here, I'm going to cover up the y, so 600 divided by 4, I get 150. Then if I cover up the x and do 600 divided by 20, I get 30 for the y. So 150 now is the biggest. And then for the last one, that's easy enough, 50, 0, 0, 50. Okay, let's see. Okay, here I went by tens. I extended that x-axis all the way out, extra. On the test, you should have enough room. All right, so let's do the first line first. 120, 0, and 0, 40. Solid line. I wish I had a ruler, and it's going to be shaded below. Okay, let's see if I can do this. Okay, so there's the first line, shaded down. Next one, which is in the red, 150. Over here, 0, 30 is over here. That one's also solid. Okay, and the last one in the green is 50, 0, 0, 50. Again, solid. And that one's shaded above. Alright, so let's see if I could figure out where my, looks like it forms a four-sided polygon. So I'm going to connect it. Okay, so there I outlined it in black. Right, now I need to approximate these points here. Okay, so this one looks like it's about 29 for the X and I don't know, 25 for the Y. Over here we got 50, 0. Okay, then all the way over here, that's easy, 120, 0. And then we have one over here, which looks like it's at 90, 15. Okay, so now we have to take those 4 points and plug them in the profit equation. And what was the profit equation? 6x plus 20y. So the profit equation was, what was it again? 6x plus 20y. And I plug each of those points in and see which gives me the most amount of money. Okay, so I did all those. I plugged in the x and the y for each of them. So it looks like this is gives me the maximum profit. So when I sell 90 t-shirts and at the same time about 15 sweatshirts, my total profit then would be $840. And there's the answer for number 4.